Yes, good evening, guys, to all of you. I welcome you all in this wonderful session on this wonderful platform that is BYJU'S Exam Prep. G1, good evening. Rohan, hello, dear. So, guys, today this is a session which is related to BARC and HAL preparation. And in this session, we are going to see some wonderful question from theory of machines. Guys, we are going to do this theory of machines in two sessions basically. Okay, so today is the first session. So in these two sessions, we are going to complete theory of machines, means all the questions from theory of machines. Okay, so this is the first one. In this, we are going to have questions from the topics simple mechanisms, velocity, acceleration, and after that, some questions are from CAM also. Yes, Jivan, I was saying that only. Today's topics are simple mechanism, velocity, acceleration, and CAMs. Okay. So other topics would be there in the second session. Actually, these are the topics which have been asked more in these examination. So based on that, I have taken these topics in the starting. Okay. So shall we start it now? Are we ready? Guys, please like and share the session in all the Telegram channels also, so that we can start the session. Okay, just wait. I feel this got hang. Okay, just wait for a minute, guys. Just wait for a minute. Just wait. Yes. Yes, guys. I feel now I'm properly audible and visible to all of you. Yes or no, please answer in the comment section. Yes, so guys, I welcome you all on this wonderful platform that is BYJU'S Exam Prep. Sorry, actually there was some issue in the PPT, it got hanged, actually board got hanged. So now I feel everything is fine. So guys, today we are having the practice session for theory of machine subject. And guys, if you see the previous year's question from BARC examination and also the HAL examination, you will see from this topic majority questions are coming from simple mechanism. So that is why I am having more question from simple mechanism, and also we are going to have the question from velocity and acceleration, because they are the topic from which more questions are coming, and also we have included the topic of CAM and follower. Okay, and we would be covering the other topics in the next session. So these are most important one. That's why these topics we are going to do in today's session, and we would be having around 15 questions from all of them. And just do share the session with all of your friends, guys, so that they can also join us, because I can see the number is very less today, as actually because of in the starting we got some issue, but now it is fine. Chandan, yes, we are starting now. So guys, let us see. This is some detail about me. So you know that I am generally taking the subjects like strength of material, theory of machines, machine design, industrial engineering, and production. So these are the subjects generally I am going to take. So guys, next I would like to say that now you know that a complete solution for your GATE and ESC preparation, that is BYJU'S Exam Prep. We are having the session related to GATE preparation engineering services. Now the BARC sessions are going on. We are also coming soon for the GATE 2023 series as well. Okay, so be ready for those. So like, share and subscribe the channel. There are two channels. There is a Hindi channel also for the audience who like to study in Hindi. So both the channels we are having English and Hindi. Okay, so for both the audience, a complete coverage. Now my dear, those students who are looking for preparing for GATE 23 and 24, or if some of your younger brothers or sister or some friends, if they are willing to do that, you can recommend them this session. Or at 5 March at 8 p.m. on 5 March at 8 p.m. this session would be. So in this session you would be getting proper guidance related to what is the right time to start the preparation, when you should study, and what are the tips and tricks to crack with a good rank, what should be the strategy for that. So all these things would be covered in this session. Okay guys, so with this we are coming with the very first question based on degrees of freedom. So this figure is in front of you. You need to find out the degrees of freedom, guys. So this figure is in front of you. We need to find out the degree of freedom. This type of question you can expect in BARC as well as HAL both, because this is a question which will not be taking too much time if you know how to solve it. I feel everybody know that it would be solved using the Kurzbach equation. So I am giving you the hint. F is equals to 3 times L minus 1 minus 2J minus H. So we need to go with this equation. Yes, Shivani have given the answer as B, that is 1. Okay, we will see. What about others? Chandan, Rohan, Jeevan. Shivani have changed the answer. Now she said C. Okay, great. What about others? What about others, guys? Okay, Jeevan is saying B, 1 as the answer. What about others? Chandan and Rohan. What would be your answers, guys? What would be your answers? Okay, Rohan is also saying 1. Okay, let us see, guys, what would be the answer, and let us start solving it. You know that it is link number 1, which is going to be a fixed link. Then this is link number 2. Then this is link number 3. This is link number 4, link number 5. Once again 1, link number 6, link number 7, and link number 1. So guys, the number of links are going to be 7. So my dear, now we are going to see the joints. When we are going for the number of joints, this is going to be a binary joint 1. This is going to be a binary joint 2. Third binary joint, 4 binary joint, 5th binary joint, 6th binary joint. Binary means where 2 links are connecting. Here 1, 2, here 2, 3, here 3, 6, here 5, 6, here 4, 5, here 1, 4. And this is going to be 1 more binary joint, and here 1 more binary joint. So guys, 1, 2, 3, 4, 5, 6, 7, 8. The number of binary joints are 8. So now higher pair, there is no higher pair. So you will be saying H is going to be 0. There is no redundant motion as well. You also know in this equation, you also have minus FR term, but there is no redundant motion here. So if you see number of links to be 7, joints to be 8, you would be applying the equation F is equals to 3 times. Links are 7 minus 1, minus 2 into 8, and higher pair are 0. So you would be having this 6 into 3, 18, minus 2 into 8, 16. Answer would be coming out to be 2. So 2 is going to be the answer. Okay, C would be the right answer. And this is first question, we have done it. Okay, now let us see question number 2, guys. Let us see question number 2. This is going to be from the transmission angle. Once again, simple mechanism is the chapter name. So this question is from the topic transmission angle. So this question is from the topic transmission angle. Okay guys, this question is from the topic transmission angle. You know, transmission angle is the angle between coupling rod and output link. So this angle is said to be the transmission angle mu. And you need to tell us actually the diagrams this is given. You need to find out the maximum and minimum transmission angle. Dear, we have not mentioned the option here. So I can write the options here. I would be writing the options. Let us say option A is 0 degree and 180 degree. Option B is 60 degree and 150 degree. Option C is, that is going to be 87.27 and 25 degree. And option D is 67.27 and 15 degree. So these are the options in front of you. Solve it, guys. These are the 4 options in front of you. You need to solve it for minimum and maximum transmission angle. This is the transmission angle actually. Okay, so Rohan is saying C is the answer. Sarvan is saying C is the answer. What about others? Jeevan, Shivani, Chandan. According to you guys, what would be the answer, guys? So when we are talking about this question, dear. Okay, Ayush Sachin is there. Ayush Sachin is saying C is the answer. Let us see. So this is a question, guys, where we need to find out the minimum and maximum transmission angle. I would recommend this is good for BARC. You can have this type of question in BARC, but there are less chances for ISRO. Sorry, for HAL. Okay, I'm waiting for others to answer. Yes, Jeevan, Shivani. Jeevan and Shivani, what are your answers? Okay, Jeevan is also saying C. So, meanwhile, others are answering. I am also trying to solve how to do this type of question. So, guys, we know that, first of all, here shortest link is 30. Okay. So, shortest link is 30 and shortest link is fixed one. We need to check whether it satisfies the Grashoff's equation or not. You can see longest link is 70. So, S plus L is nothing but 30 plus 70. So, when you are going to find out P plus Q is 60 plus 60. Okay. 60 plus 60. So, this is 100, this is 120. So, guys, 100 is less than 120. So, guys, you know, it is not equals to, it is actually 100 is less than only. So, for less than case, we also know that Grashoff law is satisfied and it is going to be a double crank mechanism. So, when it is a double crank mechanism, we can very easily find out now. So, now to find out, you know that for a double crank mechanism, we know that, my dear, that when theta is going to be 0 degree, we would be having mu to be mu minimum, and when we are going to have theta to be 180 degree, we would be having mu to be mu maximum. So these are the two conditions we know very well. So we would be using these equations. This is 30, this is 60. So when we are going for mu maximum, this is 30 mm, this is 60 mm, 30 mm, 60 mm, and rest is 60 and 70 mm. This is 60, this is 70. So for this condition, my dear, you know that this angle is 180 degree. This angle is 180 degree. So this is the condition when you would be getting mu to be maximum. Okay, you would be getting mu to be maximum. So my dear, if you see, this is going to be a triangle and you can apply the cosine rule. Okay, so when you would be applying the cosine rule, or also you know that when you were solving this equation at that time, you were putting it like in this way. Okay, so my dear, when you are going to solve this, this is 90 actually, this is 60 and this is 70, and this angle is going to be mu maximum. So when you would be applying the cosine rule here, it is 60 plus 30 ka square is equals to, other two sides are, you can see 60 and 70. So you would be saying 60 ka square plus 70 ka square minus 2 times 60 into 70 into cos mu maximum. This will give you mu maximum to be, it will give you mu maximum to be 87.27 degree. I have already calculated for you. And similarly, mu minimum would be coming out to be 25.2 degree. So my dear, while solving, you have seen how to solve it. Answer would be C for this. That is correct. Okay guys, very good Shivani. So now we are moving to the third question, guys. This is the third question, that is from Oldhams Coupling. That question is from Oldhams Coupling. You need to solve it. I feel everybody would be giving right answer for this one. Guys, like and share the session so that others can also reach to this session, because this is a series we have planned for you. And tomorrow would be the second session of theory of machines and vibrations. So now 2 sessions for Tom. Then after that, in the next week, you would be having first thermodynamics. Okay. Then after thermodynamics, I would be coming with the production and machine design. So Ayush is saying answer to be D. Shivani is saying answer to be D. Bahut badhiya. I am waiting for others to answer, guys. I am waiting for others to answer. Rohan have also said D. Okay. What about G1? Sarvan? G1, Sarvan. Very good, guys. Okay, okay, very good, Jeevan. So, dear, the distance between two parallel shafts connected by Oldhams coupling. You know that this would be, let us say, the shaft which is driver shaft, and this is, let us say, the driven shaft. The gap between these two axes is given to us as 30 mm. You know that the driving shaft revolves at 240 rpm. This shaft is revolving at 240 rpm. And what is the maximum speed of sliding of the tongue of the intermediate piece along its groove? It is asked that what is the sliding velocity. I told you the formula for sliding velocity is d omega. Here d is the offset. That is a lateral misalignment, that is 30 mm. So you would be having 30 into 2 pi n by 60. N is given to you as 240 rpm. Putting this value 30 into, that is 30 mm, so 10 power minus 3 into 2 pi. N is 240 divided by 60. So the answer would be coming out to be 0.754. Answer would be 0.754 meter per second. D is the answer for that. Okay, guys. So very good. Those who have given the answer to be D. D is very much correct answer, guys. So let us move to the question number 4 now. Let us move to the question number 4. This time it is a very easy question. This is HAL type. Okay, so this type of question you will get in HAL, because in HAL the time is less, questions are more. Okay, so in HAL you would be having this type of questions more. That one higher pair is equivalent to what? In BARC chances are less for these questions. So I am covering both types. Factorial 0, okay, is saying 2 to be the answer. Ayush is saying B. Okay, Shivani is saying B. So I feel everybody is saying answer to be B only. Jeevan is also saying 2. Sarvan is also saying B. Very good, guys. So answer is 2 only. So you know that one higher pair is equivalent to 2 lower pairs. So guys, in this session I have included both the types of question for BARC as well as for HAL. Once again, this question is basically from once again the transmission angle. So if I am putting transmission angle question more, it means the chances are more that you would be getting question from this topic. Once again, this is a BARC type. BARC type is also very you can say very much similar to that of gate type as well. Okay, guys, solve this question now. And this question is giving the mechanism like this. So first of all, you can see what type of mechanism it is, whether it is double crank rocker or double rocker. Then you can very easily find out this is the mu value, but this time they are not asking both, they are asking only minimum transmission angle. So they are not asking the maximum transmission angle. Okay, guys, yes, solve it now, solve it. Solve it. (38°, 28°, 82° or 83°? Okay, very good. Rohan have given the answer as A. Rohan have given the answer as A. I am waiting the answer from others. Sarvan, Jeevan, Factorial 0, Ayush, Shivani. Yes. Ayush is saying answer to be A only. Okay, very good, Ayush. What about others? Jeevan is also saying A. Okay, guys. So, guys, you know that first of all, if you see, shortest link is 60 mm. Then if you see the longest link is 100 mm. You know that S plus L, this condition is 160 mm. Then if you see the P and Q are other two links. Other two links are nothing but, you can see it is 60, 100, 70 and 80. So you can say P and Q. 70 mm. Q is 80 mm. So for this condition 70, 80 is going to be 150. So you can see S plus L is coming more than P plus Q. So as Grashof law not satisfied, Grashof law not satisfied, not satisfied. So my dear, you would be saying that it is a double rocker mechanism. So this is a double rocker mechanism. So double rocker means like this. It is a double rocker type of mechanism. So guys, you know when it is double rocker type of mechanism, this link would be revolving like this. This would be revolving like this. Okay. So based on these condition, if you see, when you would be having, there is a condition, you would be having a condition like this. Let us say this is 80. This is 80. Okay. So if you have this has 70, this has 60, and this is nothing but going to be 100 mm. So this is the condition for mu minimum. This is the condition for mu minimum, because after that it would be changing the direction of rotation. Okay. So this is going to be the mu minimum. So after this it is going to change the condition. Okay. So when you would be having the mu minimum or whatever be the direction, actually then you would be having mu to be more than that only. So for this condition, this is a triangle. So you know for this triangle what you can write, if this is mu minimum, you can write 80 ka square is 70 plus 60 is 130 ka square plus 100 ka square minus 2 times 130 into 100 into cos mu minimum, and this will give you mu minimum to be 38 degree, guys. So this is how this type of question can be solved. This is a specific type. I am keeping it for the exam like BARC and GATE. You can have this type of question, but for HAL this type of question is not expected at all. So I am telling you which type of question can come in which of the exam. So don't worry about that, guys. Let us move to the next question, guys. Let us move to the question number 6 now. This is the question basically related to velocity and acceleration. Nice, Shivani. So the bar rotates with a counterclockwise angular velocity of 20 radian per second. So omega is given as 20 radians per second. Okay. And a counterclockwise angular acceleration as well. Alpha is 6 radian per second square. Oh, sorry, 6 radian per second square. What is the acceleration of A? So you need to find out acceleration at A. So my dear, you can see that this is a question from velocity and acceleration analysis. You know, if a slider is present, there are 3 types of acceleration. One is radial, other is tangential, third one is Coriolis. But if slider is not there, we have only 2 types of acceleration. So for this case, A point acceleration would be there because of 2 components. One component would be radial acceleration, other would be tangential acceleration. Radial acceleration would be omega square r. Tangential acceleration is alpha times r. So you just need to find out first of all AR, then AT. You must be aware that radial acceleration is acting towards the center and tangential acceleration is acting in the sense of alpha. This is AT. So this is A radial. So my dear, you know, when you are going to find out the net acceleration magnitude, it would be square root of A radial ka square, A tangential ka square. So parallelly I was giving you the hint so that those who don't know the concept can solve it. But I can see meanwhile many of you have answered. Rohan, Ayush and Shivani, they have answered it as C, and let me check it. Great. So guys, very good. Shan Vicky is also saying the answer to be C. Bahut badhiya. Very good guys. Very good. Jeevan is also saying the answer to be C. So dear, when you would be finding out A radial, it is omega square r. Omega is 20. So 20 ka square into 1. Okay, it is going to be 400 meter per second square. And when you are going for r alpha, this is 6 into 1. It is going to be 6 meter per second square. So this you would be getting as 400.045 meter per second square. Very good Sarvan, very good Jeevan. Bahut hi badhiya. So guys, the answer for this is nothing but C. This is a wonderful question from velocity acceleration. This type of question you can get in both, but more chances are for BARC for this type of question. Okay. So let us see, my dear, question number 7 now. 6 questions are over. Let us see next question, question number 7. So question number 7 is relative velocity approach. You can go it by eye center approach as well. Let us see with which approach you are going to do this. I told you this as a special case of relative velocity approach. This is special case 2 for relative velocity approach. Special case 2 for relative velocity approach. Special case 2 for relative velocity approach. Yes guys. This is special case 2 for relative velocity approach. बहुत बढ़िया. Velocity triangle would become straight line. Rohan and Ayush have answered it as D. Let us see. What about others? So guys, quickly like and share the session so that others can also reach here. Shivani have answered it D. Guys, like today, tomorrow also we are coming with some very good questions. Okay. Jeevan is saying answer to be D. बहुत बढ़िया. Very good. Shan Vicky is saying D. बहुत बढ़िया. So dear, for this case, this is O2A, O4B. You can see input and output link are parallel. When input and output link are parallel, we know that velocity of A with respect to O2 is equals to velocity of B with respect to O4. So you know velocity of A O2 can be written as O2A into omega 2, and it can be written as O4B into omega 4. O2A is 60, omega 2 is 5, O4B is 160. This is omega 4. So guys, you can find out omega 4 very easily. This is 300 by 160. Answer would be 1.875 radians per second. D is correct, guys. So these are the types of question which we are covering here, and you will see the same in the exams as well. So let us see the question number 8. We have completed 7 questions. We are moving to question number 8 now. My dear, this is the question which you can expect in both HAL and BARC. This is a question which can come in both the examinations. Okay, so the component of acceleration involved in the motion of the piston inside the cylinder of a uniformly rotating cylinder mechanism. Coriolis, radial, tangential and gyroscope. Coriolis, radial, tangential and gyroscopic. Yes. Which 2 out of 4? Which 2 out of 4? Shivani is saying A, Vicky is saying C, okay. Ayush is saying B. So the component of acceleration involved in the motion of the piston inside the cylinder of a uniformly rotating cylinder mechanism. Very good, Shaikh. So guys, answer for this is going to be A, P and Q. Okay. There would be a Coriolis acceleration, because you know that when we are talking about this, it is mentioned that the component of acceleration involved in the motion of the piston. So my dear, on the piston, radial, tangential and Coriolis, 3 types of acceleration can come. In rotating IC engine, when we are talking about rotating engine, it is mentioned. So uniformly rotating cylinder mechanism, you know that the slider which you can see is reciprocating inside the cylinder, and that cylinder is continuously rotating. So when a slider slides on a rotating body, you will be having Coriolis for sure. So no doubt about that, the answer would be having P, Coriolis. And radial is required because the cylinder, when it will be rotating, the piston would also be rotating. So for rotation, you know that radial component should be always there. So if 2 are correct out of 4, answer would be A only. Okay, gyroscopic acceleration is not present because there is no precision happening. Tangential acceleration come when alpha is associated. But when we are talking about a slider, there is no alpha, so no tangential acceleration. So the answer for this is going to be A. Yes. Very good, Rohan. Very good, very good, very good. Yes. बहुत बढ़िया, बहुत सिंपल शब्दों में रोहन ने आंसर लिख दिया है. वेरी गुड रोहन. So let us move to question number 9 now. And guys, this question you can expect in again both HAL and BARC. Let us see how many of you give the right answer for this. This is correct for both. Robin, session start at 4 p.m. and it is once again going to be tomorrow also. Today we are covering 3 topics of TOM. Tomorrow we would be covering rest topic of TOM. So these are 2 sessions where we are covering all the questions from theory of machines. Rohan C, Shan C, Rohan C, Shan 28, बहुत बढ़िया. So I feel this is a very easy question for every one of you, because the question is asking about the number of eye centers associated with this mechanism. Manvendra, very good. Manvendra is answering as C, बहुत बढ़िया. So dear, the number of eye center in a mechanism, it is L into L minus 1 by 2. Number of links are 8, then 8 minus 1 by 2. So my dear, you would be having 4 into 7, 28 would be the answer. 28 would be the answer. Okay guys, बहुत ही बढ़िया, wonderful guys. Moving to question number 10 now. 9 questions have already been completed. Let us move to question number 10. This question is a wonderful one, and that is also related to eye center. So if you see this, you need to tell about how many eye centers are present on the fixed surface. For your reference, I would be making the figure again. Actually, this is the fixed surface. We are going to have a bigger roller and a smaller roller, and a link is joining these two. So you can expect this is link number 1, link number 2, link number 3, link number 4 and link number 1. So dear, you need to tell how many eye centers would lie. Okay, Kandula Sudhir Gupta. Okay, you are asking about the percentage. Dear, it should be considered as 60%, but for that already rules are mentioned in the annexer. Okay, so if you see the notification completely, you will get this idea. Okay, because for different examinations, sometimes they mention it differently. Like for ISRO, lesser than 60, they even don't call for written examination. Robin is saying answer is 2. Rohan is saying answer is C. Okay. So till now the answer we are getting is C. What about others? I am waiting for others to answer. Yes. Shivani. Okay, you have said D for this only or some other question? Shan Vicky is saying 2. Let us see dear, don't worry, we would be checking. So dear, when we are going for checking the eye centers, for that you already know one thing, that if this is 1, this is 2, due to pure rolling, this would be eye center I12. This is 1, this is 3, this would be eye center I13. So you know, when we have 3 links, 1, 2, 3, 3 eye centers related to them would be 1, 2, 2, 3 and 1, 3. These 3 must lie in the straight line. So because of that, this is 1 eye center, this is another. So third eye center would also lie on this line. And for that, you know, this eye center is nothing but I23. This eye center is nothing but I34 due to Kennedy theorem. I24 also we would be getting on this line. So you can see this is I12, this is I13 and I23 also would be there. So when you would be joining these two lines, here you would be getting the third eye center. Okay. This eye center is nothing but I14. So this is I14 actually, not I13. This is I14. So this would also become 4 and this would also become 4. I am making it correct for you. Actually, this is I14. So 1, 2 and 4. So 1, 4, 2, 4 and 1, 4. Sorry, 1, 2. So this is 1, 2, 1, 4 and this is going to be I24. So these 3 eye center would lie on the surface. So answer would be D for this. Shan Vicky, you got it? Okay, great Shivani. Very good Ayush. बहुत बढ़िया. So guys, this is a very good question. I feel you enjoyed this. So 10 questions we have completed. Let us move to question number 11 now. We have 14 questions today. Okay, this is the question now. This is a question now. The angle theta in radians is given as a fluctuation of time. Theta is mentioned as 0.4 pi t square. You need to find out the acceleration at t is equals to 5 seconds. So this is a very easy question actually. Okay. So let us see how many of you are able to answer this. This is using the concept of mechanics basically, but at the same time it is having a rotation about 0.0. So dear, it is a mechanics question, but you need to apply the principles of mechanics. Some calculations are involved. Actually, with the help of theta, you can find out omega. With omega, you can find out alpha. Then you know that radial acceleration is omega square r. Tangential acceleration is alpha times r. Then you know that the net acceleration is square root of a radial square plus a tangential square. Solve it, guys. Shivani is saying B to be the answer. Okay. What about others? Ayush is also saying B. Okay. So guys, like and share the session quickly. What about others? We are left with 3 more questions. 3 more questions. Okay, Ayush is getting 315.86. Very good, Rohan. Great, great, great. So dear, the answer would be coming out to be equals to 315.5. So you are correct. Actually, how to solve it? Theta is given to us. You would be putting theta to be equals to, theta is given to us, that is nothing but 0.4 pi t square. So you can find out omega as d theta by dt. So it is 0.8 pi into t. Acceleration is d square theta by dt square. 0.8 pi. So my dear, now you know when you are going to find out the radial acceleration at time is equals to 5 seconds. That is omega square r. So 0.8 pi into 5 the square into r. R is mentioned to you, then tangential will be r alpha. 0.8 pi into r. This will give you radial and tangential. R is nothing but 2 meter. So it is going to be, okay. So you would be getting a radial to be 315 and this to be 5.02. And now you know, putting these values, taking square and square root, you would get the answer to be 315.5. B would be the right answer for this. Yes, yes, yes. Yes, Rohan, बहुत बढ़िया. So Rohan is helping me to explain the questions very nicely. Rohan, thanks for that. So this is one more question from eye center approach. Question number 12. Okay. And this is a certainly new type of question you can feel. For the configuration shown, what is the angular velocity of the rigid rod PQ? This is the rigid rod PQ and you need to find out the angular velocity of that. Okay. So I would be giving you hint for that. Already VQ is given to you. If you see this PQ, then if you are assuming this PQ to be in rotation, then velocity would be perpendicular. So this is going to be velocity of Q with respect to P. Okay. So you can see if this angle is 60 degree, then this angle is 90 degree, this angle would be 30 degree. You can find out VQP with the help of VQ. That is nothing but VQ cos 30 degree. So once you get VQP, this can be written as PQ into omega PQ is equals to VQ cos 30. You can find out omega PQ with the help of this. What would be the answer? Thanks, Rohan, for that. I was just kidding, don't worry. So this is question number 12. 2 more questions after this, guys. Ayush is saying the answer to be C. Okay. What about others? Yes, Shivani. So guys, I feel you found some new question today. Like previously also we have taken a number of series, but today the questions we have discussed are completely different than that. Shivani is saying the answer to be C. Ayush is also saying the answer to be C. And yes, the answer is correct. So dear, VQ is 6 meter per second. So you know PQ is 2 meter. 2 into omega PQ is equals to 6 cos 30. So omega PQ is 2 root 3 meter per second. Sorry, radians per second. Answer is C. Very nice, guys. Very nice. Question number 13. This is from CAM and follower, suitable for both the examination. This is application based question, but more chances are there for HAL exam for this type of question. Very good, Shivani. Shivani and Ayush and Robin Richard have answered it B. Yes, Rohan, Jeevan, Vicky, very good, guys. Very good. So dear, you know that there is a constant velocity motion. There is a constant acceleration motion. Simple harmonic motion. And next should be cycloidal. So dear, what I feel is for constant velocity we have 8 jerks, 8 times infinite jerk. Here we get 6 infinite jerks in a cycle. Here we get 4 infinite jerks. Here we get no infinite jerk. So jerk is not infinite here, jerk is finite in this. So B is going to be the application for high speed we would be using. Very good, guys. Wonderful. So we are reaching to the last question for today, guys. This is the last question for today. Again from CAMS and follower. Tomorrow we would be having around 20 questions from other topics of tone and vibrations. So I'm expecting all of you would be present live at 4 p.m. tomorrow for the similar session of tone and vibration. Then in the next week I would be coming with production part, as well as along with production we will see machine design also. So 4 more sessions I would be coming, 2 for production, 2 for machine design. Okay. Shivani is saying answer to be D. Okay, which of the following is constant acceleration CAM? You know acceleration is nothing but d square x by dt square. Then dx by dt would be ct plus c1. X would be ct square plus c1t plus c2. This equation is a parabolic equation. D is correct. Robin, both types of questions are coming. Both types of questions are coming, and don't worry, I'm going to take a generic session. I'm planning it in the next, you can say Monday or Tuesday. I would be taking a session where I would be giving you more guidance related to BARC paper. So don't worry. Rohan, for 45 marks in XC, I cannot say that you would be getting something great. 45 in XC is not a very good score. Okay. So you can try this. Okay. You can try for IITs as well. Okay. I feel IIT Bombay, IIT Chennai, IIT Delhi, and also IIT Patna. There are many IITs who are taking the candidates from GATE score of XC as well. So you can try for that. Don't worry about that. Okay. So goodbye guys for this session. Thanks for joining. Tomorrow 4 p.m. remember we are going to meet again. Okay. Dheeraj, actually that depends on the type of paper, that how it was, that depends on the subject you have chosen. But I cannot say much about the score right now, but I would be saying if you are under 100 then the chances are more. Okay. So if you are under 100 rank then chances are more. So okay, so don't worry, we are going to have a session based on for BARC, and what you have asked about conceptual and all, I would also be coming with the important subject. Okay, so I would be telling you the important subjects as well in the upcoming sessions. Be ready for that. Okay, so goodbye guys for this session. Thanks for joining.